On pages 5 and 6 of our Unit 5 notes, we are solving systems using a method called y1 equals y2, which is really just a particular type of substitution. y1 equals y2 is used when both equations are either already written in slope-intercept form or can easily be transformed into slope-intercept form. So if we look at this example, we already have the first equation in slope-intercept form, and the second equation can easily be transformed into slope-intercept form. So we have x plus y equals 12, easily written in slope-intercept form as y equals negative x plus 12. Now since y equals negative x plus 12 and y equals 2x minus 3, I can set those two equations equal to each other. I can set them equal to each other because they are equal, those two y values are equal at the solution to the system. At the intersection point for a given x, the y values are equal. I now have a simple equation in one variable, 2x minus 3, which is just this right-hand side of the first equation, equals negative x plus 12, again the right-hand side of the second equation. Solving this equation for x now. Add x to both sides of the equation. Add 3 to both sides of the equation. That means the x value of my solution is 5. That is only half of my answer. I have the x value of the ordered pair, now I need the y value. I can plug x back into either equation. In this case, I would choose this one since it's already solved for y. Y is by itself on the left-hand side, making it the easiest choice to solve for y. So y equals 2 times 5 minus 3 since x equals 5. 2 times 5 is 10. 10 minus 3 is 7. That tells me my y value of the solution is 7. My solution to a system is always written as an ordered pair, x equals 5, y equals 7. And then since I used this equation to find y, I'm going to go ahead and use the other equation to check my solution. Does 5 plus 7 equal 12? Yes, it does. In this example, I would first need to transform the second equation into slope-intercept form. Y equals negative 3x plus 15. And then since at the intersection point, at the solution to the system, the two y values will be the same, I can set the right-hand side of both equations equal to each other and solve for x. Really common to be asked to use this method for a story problem because we know really are very comfortable to writing equations, linear equations in slope-intercept form. So my Bob equation, Bob has read 5 comic books and reads 10 more each week. So start value of 5, rate of change of 10. Rob has read 50, so start value of 50, rate of change of 5. So those two equations represent Bob and Rob, and then I'm asked when they will have read the same number of comic books. Great system to use y1 equals y2 since they're both in slope-intercept form. And I write this equation. Solve this equation for x. I remember that I get x equals 9, and then I'll plug that 9 back into one of the equations to figure out that at 9 weeks, both Bob and Rob will have read 95 comic books.